Introduction to the second law of thermodynamics. So before going to discuss the second law of thermodynamics, let's do a quick review of the first law. We know the first law of thermodynamics, it usually follows the energy conservation principle. So if we supply the energy Q, we will get the work, and as no engineering system can convert or transfer energy 100%, so we'll get some internal energy like this. So delta U is the internal energy. So every process in this universe, they will satisfy the first law of thermodynamics. That means the energy conservation principle. Now as we said, every process will satisfy the first law of thermodynamics. So it doesn't mean that process will take place. So what I said, you found it is confusing. So let's discuss an example, and then it will be more clear to you. So here you can see this is a cup of hot coffee. So what usually happen, if we put a cup of hot coffee in a cool place, then it will become cold, right? Because it will lose the temperature, and the neighboring surrounding air will take that temperature. So this is also, it will satisfy the first law of thermodynamics. The amount of heat is losing, it will by this hot coffee, an equal amount of heat will gain by the air, surrounding air. So this is first law of thermodynamics. So what is happening here? This hot coffee, it is becoming cold. If we want to try a reverse process, that means the coffee here, the hot coffee even become hotter, and it is taking the temperature from the cold surroundings. Is it possible? It will never take place. So this process will never take place, this reverse process. Spontaneously, it will never take place. So that means this process, it's not possible. Similarly, if we see another example here, we usually use electric resistor to warm the room temperature. So if we want to try to do the reverse thing, if we supply some energy, some heat to this resistor, the electrical wire, and can it transfer or convert this heat into the electrical energy? No, it can't. So that means we discussed two examples here. What we can see, only the it could be this two system, it can transfer heat in the one directions, but not in the reverse way. It can only transfer the heat from the hot to the cold directions, right? So the summary is, from these two arrangement, what we can say, that process always follow a certain direction, okay, but not in the reverse direction. It will never take place in the reverse directions. So what we can say, it will be one way. All processes, it will occur in one way, a certain direction, but not reverse directions. And the first law of thermodynamics, it doesn't put any restrictions on the directions, but it can't clearly tell, it can't actually identify whether the process will take place or not. I'm telling again. So if this reverse process happens, this is not the the violation of the first law, but what we said, it is not possible. So first law of thermodynamics, it can't clearly mention whether the process will take place or not. To minimize these limitations, a new energy principle is introduced, and this is called the second law of thermodynamics. Second law of thermodynamics, what I said, the first law of thermodynamics, it can't clearly tell whether the process will take place or not. So a new energy principle that can solve this issue, and this new energy principle, it is called the second law of thermodynamics. So the second law of thermodynamics, that means, what we can say here, it is actually, you can see the major uses of the second law of thermodynamics. It may be used to identify the direction of the processes, but not only directions. When it is first law, we had the formula Q equal W and delta U. So it mostly discussed the quantity. Now, first law didn't discuss the quality of the energy. Here, the second law, it can discuss the quality as well as the quantity. So that's some feature we will discuss during the lecture. And the other thing is the second law of thermodynamics also used to determining the theoretical limits for the performance of the commonly used engineering systems. Yes, so the second law also closely associated with the perfection concepts that we will discuss during the lecture. So what we said here, the second law that can tell whether the limitation of the first law was it can't tell whether the processes will take place or not, and to avoid to minimize that limitations, a new energy principle is introduced, and this is actually called the second law of thermodynamics. So we will discuss more examples during the lecture, and it is very conceptual, so hopefully it will be much clear to you if you go through the the recordings of the lecture.